Right now on Amplified, we find out how one engineer is fighting climate change by putting car batteries into buildings.
It's a whole new world, isn't it? It's an exciting new world where there's a potential. The holy grail here is storage. We make tons of power. Where can we store it at a price that makes sense?
Hi there, my name is Dusty Rhodes and welcome to Amplified, the Engineer's Journal podcast. 3 human causes are driving the change in our climate, and as the people who design the future, how engineers think about these causes is playing a vital role in the climate crisis solution. Today we're looking at one of those causes, energy emission, and speaking with an Irish engineer who is actively responding with some very, very clever solutions. He has worked at EU level, creating a decarbonisation pathway with the Include organisation, and today his Kildare-based social enterprise helps extend the life of electric car batteries along with energy storage solutions for homes, farms and small businesses. It's a pleasure to welcome the co-founder and director of Range Therapy, Eamon Stack. Eamon, how are you?
Great, delighted to be here, Dusty. And this is such an exciting moment. I think people will be interested in this.
Listen, let's set the scene first, because we're all used to cars running on batteries at this stage. But with climate change and sustainability front of mind in engineering design, can you tell me more about second life batteries?
Yeah, I think this is something we might have missed. That when we put, the Irish objective was to put 1 million electric cars on the road. Now, the deadline was a little bit too soon, half our cars. But to decarbonise transport, we need electric cars. They're a brilliant engineering solution to the problem. People don't quite realise that yet. But what happens at the end of time? So every year at the minute, we're putting 20,000 electric cars on the road. And what happens to 20,000 batteries at the end of that life? The assumption was that they would go to recycling. But after a high-powered use of a battery in a car for 15 or 20 years, they have another 20 years of life available to them as energy storage. And of course, that's the national problem. How do you store electricity? It's really expensive. We can't build more hydroelectrics. We can't build more pump hydros like Turlock Hale. Making hydrogen is a solution. It's very difficult and expensive and huge losses. But if we have batteries and we own them already, why not use them to store our energy?
So what you're saying is we get 20 years life out of a battery that's in a car, but once that's done, there's another 20 years of life in that. How
Absolutely.
Does that work?
Well, the car, when you put down the accelerator in the car, you're demanding about 100 kilowatts of power from a battery. And when you're charging it, you might even be charging it at 100 kilowatts. That's a heavy power load. And after 15 years, the lithium-ion batteries tend to just get a bit tired of that high-powered environment. But if you put them in a domestic setting, and better still in a backup setting, there's very little power. So in a house, you put on the kettle and it's 3 kilowatts. And when you're charging overnight, you're charging at 3 or 6 kilowatts. It's a light load. So you might use the analogy, it's a very happy retirement program for a very valuable battery pack.
So you're also saying then, because you're talking about kettles and houses and stuff like that, that they don't just necessarily are used with cars, but this second life can be adapted to buildings.
That's right, yes. For domestic energy storage, for small enterprise storage, and then, of course, for backup. I mean, traditionally, you would have a diesel or a petrol generator as your electrical backup. And that has to be kept maintained and running. Whereas if you had a solid state battery there, as in it's no moving parts, it'll sit there and hold the charge for years and will turn on instantly. That's the beauty of it. That the power is available instantly, and then you move from that from Centras. I remember credit unions talking about this. Like they have legal obligations to have backup systems, and then farms and hospitals. So these battery packs are invaluable.
Or even I'm thinking at festivals, or if you're out for a walk in the park or whatever, and you've got a van there that's doing fast food, but of course they have a generator that's going ruining your parky day kind of a day.
Absolutely.
Can they be used in that situation
and
as well?
Just you have your battery, and we have that. We call it the range trailer. You can pull it up, and it has lots of power, and then you bring it home at night and charge it up for cheap. So it's much cheaper than the litres of fuel that are used by a coffee shop. I think we was about 5 times cheaper for the actual business. And then we were at the the electric picnic and kind of saying, God, wouldn't it be great to change the diesel electric picnic to a real electric picnic where they're not using diesel generators for power?
We'll show them kids a thing or two, yeah, don't you worry. But listen, I mean, it's great thinking about, kind of vans or houses or residential houses. Can this solution actually be scaled up? How big can it go?
Well, if you think about the numbers of cars, so we put 100,000 new cars on the road every year. So if we were putting 100,000 electric cars on the road every year, which we should be doing within 20 years, that means there's 100,000 batteries coming off the road every year. That's massive storage, like megawatts of storage that can be available. And we need to get that then into our energy ecosystem. Our national energy ecosystem needs to program in how these batteries are coming out of cars. And they're coming out two ways. It's surprising how many cars we crash that get written off, hopefully with nobody hurt. So we get a whole lot of batteries from crashed cars, but then end-of-life cars, and just say, okay, here's a system now whereby we have 100,000 50 kilowatt-hour storage units, which can give power at 100 megawatt or 100 kilowatts each, like really powerful machines, and we have them available for our ecosystem. And so we build, a common way for larger storage is to put them in containers. And so you've got units of containers and you build up a massive storage thing. So the challenge, the engineering challenge is to plan this. This is going to happen anyway. Let's learn how to do it and do it well and do it safely and compliant. And then at the end of the cycle, so you have your new battery pack, then you have 20 years of that pack in a car, then you've got 20 years of storage, and then you have 98% recycling of all that material for a new battery pack. So you've got a perfect energy circular economy. And we need to work this out.
When we're going with sustainability.
A completely sustainable model.
Tell me a little bit about 98% recycling. How come?
Yes. Well, one of the great things about lithium batteries is the metals are in the batteries in very light compounds. They're not complex. So you have two types of lithium batteries. You have the nickel-based ones. So that on the cathode side, you've got nickel, manganese, and cobalt. Now, they're three very valuable metals, and cobalt, lithium would be premium metals within the European Union that they want to preserve, but nickel is very valuable. So that's one sort of batteries. And then the other batteries are LFPs, lithium iron phosphate batteries. And again, we want to take out the lithium and the iron and reuse it. And then on the anode side of batteries, it's just carbon. It's just graphite. And again, most graphite is made in China now because it's not the cleanest of processes. So it seems logical you keep all that stuff in Europe. Once we have it, we keep it and recycle it. And that's what's wonderful about the transition from an energy system where we just burn and waste fossil fuels to one that is perfectly circular and completely sustainable. This is a really very good news for everybody in the system, and that's what we want to promote.
Now, there's balance in everything. There's good and there's bad and there's yin and there's yang. And everything you say about the batteries we're using today are good. What are the disadvantages of today's batteries?
I mean, the problem is they use a lot of resources to make them. So we need, Ireland needs to make enough batteries for 2 million cars. Is it one? Yeah, I think it's 2 million cars we have on the road. So we need to make all those batteries. So there is a cost, a carbon cost of making the batteries. That's a negative. But that is completely offset by the fact that they can be completely recycled. So once we mine them once, we don't need to keep doing that. And once we get the manufacturing process. But the alternative is a filthy process of taking oil, heavy oil out of the ground and then invest, huge energy is required to crack oil and break it into its components. So the analysts say that the comparison in energy-wise is about 400% better. So the electric car, for instance, would be 400% cheaper than the alternative, and therefore it's not perfect, but at least it's substantial, 4 times better than the other.
They sound amazing, and I wanted to ask you about this because there are other types of batteries that are being developed. There's solid-state batteries, and then there's sodium-ion batteries. What are you able to tell us about them and the advantages and disadvantages?
Solid-state batteries, the attractiveness was to take the liquid electrolyte out of the battery, which is a volatile component. And in theory, that's possible, and they've made it for small devices. However, for scaling it, they're having difficulties. So it's in process. We might see in 5 or maybe 10 years' time if they can perfect it and get it onto the market. And then the advantage of solid state is they can charge very fast. That's the ideal. Maybe 4 times faster than the equivalent lithium-ion battery. So that's what they're going for. But I always say to people, be very careful of products in development because you don't know what's going to happen. I mean, when I was a younger engineer, we were looking at, is battery cars the way future? Is hydrogen cars the way future? Or is there something else that's going to come? 25 years on, you realize hydrogen is a complete dud. It's a complete non-engineering disaster. But that's so it looked good 30 years ago. It's absolutely ridiculous solution today. So that's in time you tell. What's the good news is this British engineer, John Goodenough, is the key inventor of both the nickel-based lithium batteries and the iron-based. He did both of them. It's quite an extraordinary story and got a Nobel Prize with others, to get credit for that. So the man died just last year. But these batteries are perfectly adequate. They have matured to a level now of technology that are absolutely perfectly adequate for what we need. Every year there's small improvements now, but essentially the energy density is at a point where it does everything we need.
Mm. I'm wondering how we can scale this up to engineering size, because a lot of people we talk to, I mean, they're dealing with wind generation and water generated power. I mean, that's a lot of power. I mean, is this solution of using older batteries then to store that power? I mean, what are the problems of making that happen, and how can we get over them? Yeah,
it's part of the solution in terms of gigawatts of power and gigawatts of storage. You're a long way from that. Okay, so that's where possibly hydrogen.
Right. Is it possible is the first thing?
Oh yeah, absolutely. But it's a major contribution because it's going to scale anyway. Like, we're going to put 2 million electric cars on our roads. That's in process. And we also have lots of batteries and other applications, and therefore they will be available. It's the key engineering challenge here is to take full advantage of them in a safe way and make sure we get the maximum value out of these things. Like, we can start from a point where the Environmental Protection Agency might view a second life battery out of a car as a hazardous waste. Like, that's a problem we need to deal with. Where we need to get to is this is a national asset. And that's where the engineers need to take it away from the EPA and says, don't dump these really valuable entities for us. And yeah, I think your point on scaling is important. There's a certain limit to it. It might get up to 1 gigawatt of storage, but we would need more than that. We use 10 gigawatt hours a day or whatever in Ireland. We use a lot, but it's significant.
And one of the things that I learned in one of our other interviews was with wind storage. They're saying they can store stuff in batteries, but how long does it stay stored in the battery for?
Oh, I think
can you put power into a battery in a long time? Yeah.
Oh yeah, no. I figure there will be loss. There'll be 10% loss in the process of putting it in and taking it out. But in terms of storage, no. I think it'll, a battery pack, we've seen them sitting there for a year and very little deterioration. So it's great. It's great storage.
And what have you heard then about grid-scale battery storage systems? Has anybody tried it?
Oh, yeah. There's 2 systems. One is, like, the leaders in that are Tesla. Say an example is far away in California. So they have these huge mega packs. So they have, 400 megawatts of storage in a center. Right. So that's one amount of storage. And it's really successful because it instantly responds to grid demand. So this is the thing. Stability in the grid is as important as the power, and this thing can instantly respond. And they've done the same in South Australia, where there was this famous project where Tesla said, we'll do it in 100 days or we'll give you your money back. And they did it. They built a 250 megawatt storage in South Australia, and that solves their grid problem. And they couldn't believe the return on investment was massive. So this has been done in quite a few places. So that's one way to do it, large storage units. I think there was recently one installed in the UK as well. The other thing then is in Tesla has these domestic storage units. They call them Tesla Powerwalls. So they would be 10, 20 kilowatt hours of storage, but they network them in California. And so they have this software called AutoBidder, and the AutoBidder is bidding for power to buy and sell power, and it has customers, thousands and thousands of customers who have signed up to this VPP, virtual power plant. And so whenever the grid needs power, instantly they can turn on these domestic units. So you have the large storage units, and then you've got the networks, small networks of thousands of units. And this is live. This is working. This is the future. So when we're installing battery storage in domestic setting or a small business setting, our medium-term objective is to network all them together, so that we will be able to trade with the ESB and say, we've got 1,050 kilowatt hours of storage. More importantly, we've got power available to you instantly, so that if the grid needs stability, we can provide that, both at a microgrid, a local grid area, and more nationally.
You're kind of leading me on to another thing that I'd heard about, and this is vehicle to grid, V2G. And it's a kind of a smaller version of it, where it's the cars are drawing power, of course, when they're charging up. But then when you plug them in at night, the computer is able to figure out that, well, you know, you're not going to use that much power tomorrow, or based on your usage or whatever. So it's putting power back into the grid. Have I got that right?
Absolutely. That's the same thing. That's the same thing then as the virtual power plant, where all the cars are plugged in, and then you choose. You say, okay, I'm using my car tomorrow for this distance, and so I need this much power. So you can have some of the rest. And sometimes they only need a small bit of power. They just need it available. So currently in the UK, this has been piloted by Octopus Energy. So it's not far away where they're actually piloting, and this will become standard, I think, where cars will be plugged in. We've less so in the US. A big thing is they have lots of school buses. So they're transitioning school buses to VPPs, whereby they're becoming, electric school buses sitting there all day doing nothing, and they're a power source for the grid. So it's a whole new world, isn't it? It's an exciting new world where there's a potential. And the holy grail here is storage. We make tons of power. Where can we store it at a price that makes sense? And so if you have 2 million cars on the road, well, that's a storage bank that is massive. And then if you have all these second life batteries in houses and whatever, you build up. So that's where I think we need to design our future grid with this in mind. This is now, the door has opened for us, and we're, in a sense, leading the way, but by actually doing this.
So that's amazing. So instead of energy going into a car in the form of electricity, batteries, even petrol or whatever it happens to be, it becomes a transactional thing. So the car kind of goes, well, I'm going to need this. I'm going to run out of whatever storage, so I'm going to put this back into the system while I still have it. It's mind-blowing, Eamon. But it's mind-blowing.
There's something more significant here. So, you listen to, there's a lot of negativity about electric cars from sources which are probably the oil companies themselves. They don't like this change. It's going to cost them a lot of money. However, think about it. They say I'm from Kerry, right? Kerry has thousands of wind turbines generating power. So at night, there is tons of energy available at night. So all Kerry transport could be powered by Kerry energy at almost no cost to the system. It's already there. This generating capacity is there. The infrastructure is there. Imagine that, transitioning from importing fuel, mostly from Saudi Arabia, to power our transport, to using our own energy. Is that a shocking thing in terms of macroeconomics? Stop importing stuff that is dirty and polluting and a problem for us. Let's use our own energy to power our own lives. And I tell you, this hasn't happened since 100 years ago this summer, when, I don't know if you know this guy, Thomas McLaughlin, arrived home on his summer holidays from Siemens in Germany, 100 years. And he approached the Irish government and said, my company is interested in building the world's biggest hydroelectric plant in Ireland, on the Shannon. And we're also going to build the first national electric grid. And they did that between 1924 and opened it in 1929. Mega project. We were energy independent with sustainable energy in 1929. And it was, I just love the visionary stuff of that, to say, let's see what is possible for Ireland. And in that case, they took Ireland, which was a small, many little microgrids that were very dodgy, to transform Ireland into have 100% power generated from Ardnacrusha, and to build the first national grid, which of course we should be very proud of, because it's still an outstanding grid. And that grid today has wind capacity that we don't use of as much as a terawatt hour. Enough energy that we don't use every year to power Galway for 2 years. That's how much energy we don't use. Let's learn to harvest that. So where in terms of the individual household, where this has an effect is there is energy at night as cheap as 5 cents a unit. And daytime energy is 35 cents a unit. So if I can fill up a battery with 5 cent electricity at night, my ESB bill goes down 5-fold. And this is not imaginary. This is actually the economic reality of today. And as we expand our wind turbine infrastructure, surely in the middle of the night, the price of electricity can only go one direction. And electricity will be really cheap. So as a national strategy, this is absolutely fantastic. And that's the story I want to say to people. We really need to stop purchasing polluting energy sources from Saudi Arabia. They have enough money. They don't need our money. We need our money. And it makes macroeconomic financial sense and, of course, domestic financial sense. And it is the pathway to dealing with our CO2 emissions, which I'm told we're going to be fined $1 billion a year from 2030 if we don't resolve this issue.
Well, listen, so you've been talking about what we did 100 years ago. Here we are today. There is a brilliant solution. The one you're talking about is one of a number of brilliant solutions, and they're all there. Is Ireland actually implementing any of these new technologies? I mean, should engineers be thinking about this and starting to get these things into their designs?
No, absolutely. I think lots of engineers are involved in this. The ESB is a bit of a dinosaur. It's difficult to move. They might have done some of this planning 20 years ago, but at least they're doing it now. We're introducing renewables. The national strategy, I heard a presentation in the Engineer Ireland conference last year on the ESB's national strategy. So it is offshore wind would be the primary source of energy. And that they're building the motorway to Foynes. It may be a civil engineering project, but ultimately it's going to a port that is going to allow us install a massive capacity of energy in the Atlantic, where there's tons of energy. So we're doing this. Our bit is in terms of when you're generating that energy, one place we can store it is this new resource that we might have missed, we mightn't have seen, and that is like you said, the vehicle to grid electric car storage. But also then the second life of those batteries in other storage, domestic and business energy storage.
Yeah. And even though we're talking about cars, this can equally be applied to buildings. You just look at a building as a big car that doesn't go anywhere.
That's right. Absolutely.
And if you think that way, well, the same principles apply, don't they?
Yes. So can I give you an example here where we've been talking to farmers, dairy farmers. There's 18,000 of them milking at peak time for energy. In the evening. So if they can purchase that energy really cheap in the middle of the night and use that to power their milking parlour, they would save themselves between 10 and 20,000 euro a year. And so the batteries are there. We figure for an average dairy farm of about 80 cows, they would need 80 kilowatt hours of storage. That's a Polestar battery pack. And we have lots of them. So we're already working, with designing a system to go into dairy farms, and the scale is 18,000 farms.
When I'm looking at your website, Range Therapy, you've got some great pictures that really give an example of what it is that you do. And basically kind of you convert a trailer that somebody can carry around behind their food van or their car or whatever it happens to be or whatever. How can you scale that? Have you scaled that up then so that it's more than just a trailer? Have you actually installed this system into buildings? So we
the trailer is the mobile version, and then the static version is the range wall, the house one. So we've done 10 houses. We've done houses. And so it's interesting then for people listening to say is compliance is a huge issue here. And what has slowed us down? So what we have done over the last 3 years is we have upgraded 80, nearly 100 cars with batteries that came out of crashed cars that were bigger than the old batteries in the car. So we swapped out the old small battery for a bigger battery from a crashed car. Surprised me how many crash cars. So now we've accumulated all those batteries, but we weren't willing to install them in a domestic setting until all the engineering compliance stuff was resolved. So one of the issues was that if you have a battery pack and something goes wrong, you want the control system to have the ability to turn it off, to intervene before it moves down, because all engineers would know the ultimate danger of a lithium-ion pack is thermal runaway. So if it gets hot, it gets extremely hot and will cause a serious fire. However, once you have the battery management system that monitors that battery pack, it just turns it off before that ever happens. And so, for instance, the oldest production electric car is the Nissan Leaf, and there has never, ever been a thermal issue with the Nissan Leaf in nearly 1 million units, in thousands of crashes. And that's because the battery management system turned it off before it went down that route. So in terms of putting them into houses, we had to make sure we could do exactly the same thing, that we would get the data from the battery management system in our control unit and then have the capacity to turn the battery off if there's any deviation from the key thermal or voltage values.
Can you give me a sample of one of the houses that you've installed the system into, and just kind of give me an idea of how it worked and the problems you had to get over and the solutions you came up with, and how it's benefited the house?
Yes, our first installation was in Kerry, and it was a new built house that had a air source heat pump. So it was a completely electrical house, and it's very passive. So the thing we needed was to make sure that a solar system was installed by a local company, Gilroy Energy in Kerry, and that the inverter they used to invert the DC to AC energy for the solar had to have the capacity for the voltage of the battery pack. So cars generally use 400 volt systems, and therefore the inverter had to be able to handle a battery. So we were able to intervene and say, we need this particular inverter, which is an Austrian Fronius inverter that can handle 400 volts in that case. And that was the only intervention. Then we went to the house and we had to find a location for the battery pack. So it's kind of 1.6 meters by 1 meters, 350
Big
kilos.
enough.
350 kilos, Dusty.
You're not taking that on a plane, are you?
You're not taking that. Luckily they were building a shed with the house, and so we located the battery in the shed, and then the challenge was to wire the cables from the battery pack into the inverter. So it turned out to be a 40-meter journey. We thought it would be much shorter. So that was one of the more challenging ones. 40 meters of cables. So you've got the power cables, and then you've got the data and control cables going. And then beside the inverter, we put our control box. So the owner of that house, after we went back after a couple of months, and he said to us, he's an accountant, and he said, "This is extraordinary." He said, "I don't pay for any electricity. I don't pay for any oil or gas because I heat my house with electricity. And I sell electricity back to the grid and get a free pint every day." He said, "That's a good deal by any accountancy terms."
Do you know what? It's a pity this is an audio podcast, because I really want to stand up and applaud you, Eamon. That's just brilliant. And as you say, the challenge now is to kind of take that now from that size and to adapt it to, I'm going to say skyscrapers just for the sake. How can engineers listening now and kind of going, this is a really good idea, how can they better educate clients or even their own bosses about the benefits and proper maintenance of battery systems?
Yeah, I think we need, one of the factors that limited the deployment of battery electric technology was the cost. And now we've found that we actually already have Irish batteries. We don't manufacture them, but we have lots of them that are very low cost. So that we can overcome that problem. So what you need then is the compliance stuff. So you just need, so I've a friend was asking me about it in his house. And then he stopped and said, "I have a dental practice that we use a very significant amount of energy during the day." He said, "Could you put a battery into my dental practice?" And he said, "And I don't own the building. We rent the building. So I'm not going to put solar panels up or whatever." But he says, "Can you put a battery in the backyard so that it charges up during the night or whatever?" And I said, "No problem. No, you know, it might be 6 to 8 grand to power the operation, maybe 50 to 80 kilowatt hours of storage." But I said, that is actually no problem. In fact, having a Kia Soul battery we already have, that would be perfect for your job. So that's it. It's just a matter of being able to use it. Now, one thing interesting, Dusty, is as well, from an engineering point of view, you might be tempted to break up a battery pack to make it in the format you want or the voltages you want. But actually, if you can use the batteries already certified for automotive grade use, in there, you have a very high quality certified unit. And so there's a huge advantage of just keeping the battery pack, taking it straight out of the car in its case and using the battery pack as is. So that's part of a very good strategy. And that's what they do with containers. They take the physical battery packs out of the cars and put them on shelves and then connect them together. That's the best way to do it. Best strategy.
One last question for you, because you said the C word, not me. Compliance. Where do we stand with getting the authorities to rubber stamp and approve these things?
Yeah, so this is well down the road here. The EU has looked at this, and in terms of cars, they have done something that was a little surprising but sensible. When you're now scrapping an electric car, the car has to be split between the traditional car bit and the battery pack. So the battery pack has to go down a different recycling route. And then at that point, the EU has recognised that second use of batteries is growing industry, a really important industry. So they've allowed that space, and they have defined then some of the requirements that are needed. So a automotive battery has a battery management system, and it's got a metric called the state of health. So what they're saying is that the battery has to be better than 50% state of health to be usable in a domestic setting. And then after that, it's essentially end of life and ready for recycling. So what we have introduced then in our system is this monitoring system of the state of health of our batteries. And so that's locally available. And it's also now we're building an external server to monitor all our batteries so that once they approach the end of life, then we will take them out, send them to recycling, and then replace them with similar units. So that's what's important, that in terms of compliance, that we not alone are we aware of this, but we actually have systems in place that can deal with batteries that fall below 50% state of health.
Somebody is listening today and they want to find out more and dig a little bit deeper from an engineering perspective. Where would you suggest they go? Are there any particular websites or books or something to watch on Netflix? Or
yeah, well, no, rangetherapy.org, our site is probably a good place to go. Again, it's relatively new, so people are just going to have to try Engineer Ireland podcast. There might be an interesting podcast there. And we'd like to see more articles. We'd like to see in the journal and so on. So that's it's a new world, and we're beginning to discover.
Well, actually, I do have to say that, and I would recommend it, because you're not like a limited company, a for-profit kind of a thing. You're a social
enterprise. Social enterprise, yeah.
Social enterprise. Okay, so it's more important what you're doing as the profit side of it, so to speak. Absolutely. And I found that with the website, which is rangetherapy.org, where you go, that there's a lot of actual genuine information that you can find out about what Eamon is doing. And it's not like it's not a hard sell kind of a website like sign up here, blah, 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 whatever. There's a lot of really good information on that. So I definitely recommend. The link to Eamon's website is in the description area of this podcast. So just click on that and away you go with it. Listen, Eamon, is there anything else that we'd like to add in, or any final thoughts you want to share with us today?
Yeah, I think in order to develop, we need engineering resources into that. We need academic people to look at it, and we need work on the compliance side, because those EU regulations haven't yet been implemented and how they're going to be implemented. And we want to make sure that engineers inform how those regulations are implemented, that we don't do something silly and stop ourselves from going down this excellent route. So there's also a temptation that there have been recycling plants built that are hungry for batteries. It says, let's not give in to the temptation of giving them all our batteries when they have another 20 years of life available to us. So there's a tension there that we have to live, an economic tension, where we don't want to be, where you have hungry, new battery recycling systems built, but the supply isn't big enough yet to merit the investment. So the temptation is to give them all the batteries. Don't give away our Irish batteries, please. Let's use them.
Listen, Yeah, we did it 100 years ago with hydroelectricity. We can do it again.
That's it. Yeah, it must be. Fantastic.
Listen, if you'd like to find out more about Eamon and some of the topics that we talk about today, we have notes and link details in the description area of the podcast, as I said. But for now, Eamon Stack, engineer, co-founder and director at Range Therapy, thank you so much for being an amazing guest today. Thank you.
Delighted, Dusty. Thank you indeed.
If you enjoyed our podcast today, do share with a friend in the business. Just tell them to search for Engineers Ireland in their podcast player or on YouTube. The podcast is produced by dustpod.io for Engineers Ireland. For pre-release episodes, more information on engineering across the country or career development opportunities, there are libraries of information on the website at engineersireland.ie. Until next time, from myself, Dusty Rhodes, as always, thank you for listening. Take care.